This video is about building a hot wire bender for acrylic and also cutting some acrylic with my Xtool D1 PRO 20 watt. Now this bender, I've always wanted to build something like this, and I had an old HP all-in-one computer power brick that's a 19 volt at 9 amp power supply I decided to try to use. And to test it all out, I made this little setup, and turned out to keep from burning the wires up, I had to add a motor controller that I had laying around. So that just kind of controls the voltage to it. But those was my first little test setup that I made. A piece of plywood, a couple brass screws, and a batch of nichrome wire. I tried some different sizes there. And I'm just going to show you what I started out with, just to try to get an idea if I can make something that's workable out of it. And you have to remember that, you know, electricity can kill you and red hot wires can burn you bad, so you have to be careful if you attempt anything like this. And here's an assortment of nichrome wire that I picked up to test with, and it turned out that the 22 gauge was the one that I'm using. It's the heaviest of them all, and it's one that lasts the longest under this kind of voltage. So here I'm just going to just show you. This is the first time first time I'm really videoing it, but I did go through several wires and stuff trying to get something that worked. And also wound up wiring, not going through the spring with the voltage because I melted down a couple springs and stuff. But you'll see there's a piece of acrylic, I think, trying to remember, this is about a 3 mil, actually not 3 mil, it's about 3 millimeters thick. And just heat it up. Actually, that's a 1.5 millimeter there. And just hold it against something square for a while till it cools. And you can see it bent pretty good. A little bit hot. You can see some bubbles in it, but I was a little bit close to the wire, and this was just kind of, just testing it out to see if it's going to work out in the end before I built anything. And again, I just turned the voltage control up, and that little piece of plastic spacer that I have is only about 1 millimeter above that hot wire, so you can see it's not, perfect conditions for bending, and it takes about 20 seconds to bend this 1.5 millimeters. And there you can see how easy it is to bend. And I've been cutting a lot of acrylic with the Xtool D1, and I just wanted to be able to make some bent parts with it. So, that's how this all started. And here's a piece of Lexan. Now this, you can see the one bend I put in it, I cold bent that in the press brake out in my shop. But I wanted to see what happens with heat, and I had to leave it on there for a really long time. I'll just speed this up again, and turns out that it took a long time and I had to overheat it again. You can see I got a nice bend, but I got that overheating there, not like the cold bend. So I guess I'll stick to cold bending the Lexan. And then this is a piece of 1/4 of an inch plexiglass that I had laying around. Decided to see if that's bendable, and that did take quite a while to heat up too. And as I did with the other Lexan, I overheated it a little bit, but it just proved to me that I could bend it by controlling the heat and the time. I should be able to bend it okay. So there it is, and again I got the the overheating, some bubbles in it and stuff, but it did bend up nice and strong and everything, so pretty happy with the result. So it's time to take this a little bit further. And I just play with stuff like this before I start building a machine. So then to make the tool, I had some old aluminum extrusions from one of those 3018 machines that I had gotten as a prototype that didn't work, that I disassembled, and decided to use them. And then I had some of this melamine coated particle board stuff that turned out to be exactly 20 millimeters thick. So I'm using that, and then I'm just going to grout that wire down the center of it. So really it was mostly scrap that I had laying around and building this with, and that power supply actually going to tuck in underneath there, so it'll be like a little machine. Now I just started, I had some pre-drilled holes in those extrusions that I used to mount the whiteboard on there, and took some double-sided tape for now to stick that power supply under there. I did cut a bracket on the Xtool of acrylic later to hold it, and a couple screws for feet to stand it off. And I needed to mount the motor controller, and you know, as I said, this is really kind of like a butcher job. I'm just throwing together with stuff I had, so I'm just going to put some, use some screws and some little nylon standoffs to mount that controller up underneath there where I can, you know, in the front where I can easily access it. A couple spacers and a couple Craig screws. Then the only part that I really did go out and machine was some side plates. I wanted something, these are steel, and I wanted something that would cool down the plastic fast. So you can see I machined a couple side plates that go into the extrusions with the little T-nuts. And then I needed to start cutting some acrylic parts for it. And this is the stop that I cut for the one side. So let's go over to the other side, and you can see I cleaned up over here. I actually got rid of some stuff, and I got a new cabinet because I do have a CO2 laser coming in the future. Really nice desktop one that's supposedly got a 10,000 hour tube life. So we'll see that. But in the meantime, I picked up one of these Home Depot cabinets on clearance, and it's perfect for holding all my materials and all my laser accessories and parts and all the different plywoods and samples and stuff like that. And there's a drawer for the plastics, and it really did help me clean up. And I got a drawer now for tools, and one for just, you know, samples that I'm keeping just for settings and stuff like that, and then the parts drawer of things I've taken apart. So, and along with the bottom, a lot of parts in them too. But this will give me a place to put the new laser on, and I've still got this D1 PRO, the 20 watt one, which is my favorite now, and also this Portor LM3. That one's been a really good working laser too. I like that one too. Not quite the power, but it's just, you know, it's got a finer beam in it, I think. And then I've got this older Xtool, the 10 watt one, that's probably going to go out in my other shop once I get the new one. So I've been cutting a lot of acrylic lately, and I found this black cast acrylic on Amazon that I've had my best luck with. I get really good cuts out of it, and you can see there's really not a lot of burning or smoking or anything. Now I do have to do 3 passes on it. I think I'm doing 100% power and 10 millimeters a second to get the cuts. You can cut it with 1 pass, but it turns into just a mess. It just melts it and destroys it. But here you can see just how nice and fine the cuts are in the acrylic. Not very much smoke, but you do want to have a good exhaust system on it when you're cutting acrylic. And then I'm going to just shake those pieces out. And there I have some parts for building my tool, a couple more stops. So you can see just how handy these lasers are when you start getting into plastic. And there they are, really beautiful cuts. I'm real happy with the quality. And actually I'm excited to be getting a CO2 laser soon, just to be able to cut clear also. So here's some orange plastic. This is some of that sheet that I bought a long time ago. And I'm making some insulating washers and stuff like that. So, you know, it's really easy to build parts using this Xtool. And there you can see that's 5 cuts, 5 passes to get the orange cut, but still beautiful cuts, and just a little bit of burning around the edge, but nothing you really see. So then I've got some, for this bender, I decided to put some stops on either side just to be able to, you know, do repeat bends and stuff like that. So I just made little stops that'll slide back and forth. And there you can see, you can just put it, set it, and then, you know, go part after part and just bend it. So I put one on each side. So here's the one for the other side. And I needed, I can only cut about 3 millimeters of the acrylic right now. So what I did is I just cut 2 pieces and I'm super gluing them together. Now it's funny because in the past I would have cut pieces like this on the CNC router, which really took a long time and made a mess. Using a router, the chips, they get real staticky, and you've also got deburring and stuff to do at the end to clean things up and stuff. So you can see just how quick and easy this laser does. And here's a couple more pieces I need to apply spring pressure to the actual nichrome wire. And I just drew them up, and I'm just gonna cut them out quick. And again, there you can see this Xtool. I mean, it just does a beautiful job on these parts, and they're actually very accurate. You can see I made them to slip over those spacers for to spring load it without any play, and they came out perfect with no modifying later. So there's the one side. I made a little brass block to make it quick to change the wire and make it adjustable up and down from the surface. So that's all adjustable. And then it's spring loaded because that wire stretches over 3/8 of an inch when you heat it. My first attempts, I didn't use a spring, and I just got like big buckling in the middle. So here we go. I'm just going to stick this other side on. You can see I'm using some standoffs. And I'm just putting some springs I had laying around. They're a little bit too heavy for it, but they still work. And then I cut some acrylic washers too. So everything's all well insulated from each other too when I put this together. And it will be easy to just change out the wire and play with the different size wires too for different types of plastic. Plus the actual power hooks to the bottom of the brass block, so I don't have to mess with that to change a wire. And there you can see, so I'm just going to mount that, and I'm going to start with being 2 millimeters below the surface. Alright, so I needed one more stop I wanted to make for bending angle parts. And again, I'm back over there, and this is that black cast acrylic. Again, perfect cuts, no burning or anything. One thing you do have to do though is clean out the laser when you're doing a lot of this acrylic with the cover sheet. So there's a part I just cut, and I want to put a little bend on there so I can grab it with my fingers. So this is my first part I'm actually trying to bend with this. And you can see it's you can watch those that wire expand, and those springs just kind of extend out and keep it taut. And this takes, I think this 3 millimeter took 30 seconds to heat up to the point of being able to bend it. And I found that if you don't go too soft on it, you just kind of get it so it'll start to bend, and then hold it up against that steel. It cools really quick, and it'll stay at the 90 degrees. So there it is, my first bend, and you can see having a little more controlled conditions, it really came out perfect. No burning, no melt, everything just came out right. No bubbling, all nice, smooth looking, straight. So I'm happy with the way it's going to work. And then I did throw an insert in that top there, so I can just slide this around and use this for actually bending angle pieces, because I've got a couple angle things I want to make. And then I put some offset slots too, so I can handle different size pieces without having it extend over that heater wire. So that's the final stop on it, and you can kind of see how that's going to work. So I just figure I'll take a piece of scrap here and just see how it bends something that has all different thickness webs on it. You can see there's just what I cut those insulators out of, and I just wanted to see how that would bend. So again, that's 3 millimeters thick, and I did about the same 20 seconds on it, and the wire is down 2 millimeters. and it just started bending at about 20 seconds, and there it is. So I did get a nice, angled bend on there. You can see the bends all came out perfect, even though they were different webs and stuff like that. So looked like it's going to really serve my purpose well and not cost anything. So that's the best part of it. So then I have to make a front and a rear panel for it. Turns out the Xtool was not big enough to cut them out unless I went on an angle, and I didn't want to waste a sheet. So I decided to do this by hand. And I did put a radius on the front of it. You can see this acrylic you can machine with woodworking tools too. And then the easiest way to cut it I found is my bandsaw. My table saw actually melts it. It just cuts too fast, and I don't have a plastic cutting blade, so it melts it. And the bandsaw does a fairly decent job with it. So a couple drilled couple holes, put it on the front with a couple Kreg screws and a little bit of super glue just to clean it up a little bit so it doesn't look all ugly and have all the the stuff underneath sticking out. And there you can see the front I made a little bit longer so I could put a hole in it for that pot on the motor controller. And then I went up to my Cameo 3 and I made a couple stickers for it. And there's what it looks like. Now I also did cut some more acrylic parts for refrigerator magnets. You can see I just cut the acrylic out and put some magnets on. I bought on Amazon, and they come with like a double-sided tape for mounting them. So if you don't have any little kids or dogs around, they're fun to make. And then I also bought a assortment of colored acrylic from Amazon and found out some of it was actually cuttable. The green was cuttable, the yellow, the red here, not too pretty a cut, but it did cut. A little bit burned around the edges. And this lime green cut halfway decent. A little bit of burning though. Had to go a little bit slower with that one. And I wrote the numbers, the speeds that I use on each sheet. And that one there got really, really, really hot, so I don't want to cut that with this anymore. But the light blue was no good, couldn't cut it. Purple, turned out I couldn't cut that either, no good. And the same with the white, I couldn't cut through that one. And the strange thing is, the orange that I bought there, I could not cut through. But this orange sheet that I have that's about the same color and everything else is not cast. It's extruded acrylic, cuts like butter. So, I don't know. I guess each material you buy, you're going to have to try a piece and see how it cuts. So then I decided to just run a little refrigerator Christmas ornament magnet. And here you can see this is the green material I bought, and you can just really get an idea of just how nice this acrylic does cut and how clean it does come out. So that took like I think that took 5 minutes to cut because I had to make 5 passes on this. And there you go. Just have to peel that backing off. I guess I should have taken that off before I cut it, but I didn't think about that. Once you get into intricate things, it does get to be a pain to peel off. So there it is, all done. You can see what it looks like. And then to make a refrigerator magnet, took a magnet, put a piece of the double-sided tape on it, and I'm just going to stick it in the middle there where you don't see it. And there I have a refrigerator magnet. And like I said, you want to be careful with these if you have kids or dogs around that could swallow them. But for the most part, they do work out nice. Now, this little tool I had out in my shop, I bought at Harbor Freight about 10 years ago. It's a little plastic thickness gauge that I found in the drawer, and I brought it in. I've been using it to measure the thickness of everything that I cut to get an idea. It's kind of like a little junky $3 tool, but boy, did it work good. I don't even know if they still make them, but I'd recommend if you're ever in Harbor Freight, look for something like this. So there it is. In the end, this is, I just wanted to show you can cut acrylic good with this Xtool. And you can actually cut it out and make parts to make machinery. And there you can see those little orange spring spacers on the end. Oh, okay, here we are. You can see I've got my settings 1.5 and 3 millimeter, both different heats. And you can see I doubled up those orange spacers because the springs were bowing them a little bit. And in the end, I'm real happy it's going to do, what I do for some future projects. And, it looks like it's going to do a really good job on everything but the real thick materials. And maybe I can get times and temperatures down eventually for them too. You never know. And I'm real happy the way it turned out and how it works. So, it didn't really cost me anything, so that was the best part of it. And again, you can see I doubled up on those orange pieces on the end, and I cut a little bracket with the D1 to hold the power supply in place. And that little motor controller. I'll put links to the motor controller and that actual acrylic that I like cutting and stuff like that. But you can see it's a nice compact little all-in-one package that should serve me well, and hopefully it'll last for a while. So if you want to make precision parts out of any kind of acrylic, check the acrylic out, make sure it cuts it nice, and this Xtool is actually capable of that. Does a really nice job, as you can see, making parts, and it makes great refrigerator magnets too, and pretty much it really does make building little tools quicker and easier for me. And there you can pretty much see the capabilities of the D1. And I'll put a link to those little magnets that I got on Amazon. They're pretty cool for making the little refrigerator magnets. And stay tuned for the a review on the latest and the greatest new desktop CO2 laser that's coming out shortly. Thanks for watching. Please subscribe.